Our next speaker is Professor Ray Harwood from De Montfort University in Leicester. Ray was head of department in Gala Shields, where Gordon works, until 1989, and since then he's been head of department of textile design and production at De Montfort University in Leicester. He also has lots of other interests and activities which I won't waste time going through, I'm afraid, at this time.
Ladies and gentlemen, thanks for coming. I have rather more to say than I have time to say, so I'm going to whiz through to some extent the slides that we have. But just before we start, just to say that this isn't only my work. Jane Wyatt and Ian Booth are co-authors of this particular paper. I've specifically said in the title, a slightly extended title, to say that we're quite interested in the processing of fibre on a cotton-based system, on a cotton system. So I'm interested in short fibre flax as opposed to long fibre flax. And I hope you all appreciate what flax is. Of course, it's a Bast fibre. The fibres are formed in a ring around the outer surface of the plant. At the very outside we have cuticular layers, and inside we have the softer tissue which we talk about as the shive of a Bast fibre, in technical terms the xylem. There's various other factors here, but I don't have time to go on and look at it very quickly. Okay, we have a series of non-cellulosic components which we're interested in. We're certainly interested in the importance of the surface wax. That's a crucial factor. Pectin is the main material which is removed during retting. We have hemicelluloses, which we are not going to talk about very much today. They're not critical. But we also have a compound called lignin, which I believe is. For the chemists amongst you, what pectin is a generally seen as a partially methylated polygalacturonic acid. The important thing here to note is we've got three carboxylic acid groups that make this particular compound soluble in caustic soda. We heard earlier this afternoon, of course, that you can remove pectin using alkalis and other components. We see that hemicelluloses are nothing to do with cellulose. They have a completely different basic structure. But the important thing here is that we have an aromatic polymer, lignin. Lignin is a very complex compound. It's made up of essentially three monomers, which are unsaturated monomers of this type, and they combine together in about 16 different ways. I'm not going to go into the comparison of flax and cotton, though we are interested because we're looking on the cotton system. But essentially, we think about flax fibres as falling into three types. Line fibres, or linen flax, long assemblies, anything up to 1 metre long, but normally about 60 centimetres long assemblies of ultimate fibres. Short fibre tow, the byproducts of the flax industry, of the linen industry, used to feed into the market for the production of cotton and linen blends, particularly in the fashion end of the market, where you chop the fibre up and subdivide it further and hopefully process it well on a cotton system. And then we've got the ultimate fibre cells themselves, which, although this is a little bit clear, they vary in length, depending on the variety you choose, between about 15 and 28 millimetres, and they have diameters of about 10 to 30 microns. If you can completely subdivide the fibres in flax, then you come down to something which is somewhat coarser than cotton, but certainly processable on a cotton system. The traditional flax production system requires you to grow the flax to some particular point in its maturity. It's normally pulled. I'll show you what that is in a moment. It's retted and it's decorticated. And I've used the word decortication rather than the linen term of scutching that we use to separate the shive, the non-fibre material from the other material. Flax plants are pulled out with specialist equipment, which is relatively expensive. The fibre is laid in swathes, as it is here, that you see in this particular photograph. And these swathes are turned from time to time, and as the plant dies, it gets attacked by microorganisms, and it rets. And finally, it's baled. We're coming to the, I'm sure most of you know about these processes, but the important thing about this is that the bale, if it's being collected in normal processing, has to contain somewhat less than 20% moisture. 15% is not a nice amount of moisture. Otherwise, retting will continue, regardless of the fact that the crop is being harvested. Okay, retting is essentially the degradation of the non-cellulose material, or should be the degradation of the non-cellulose material. If degradation of the cellulose material, and the fibres in particular, occurs, then we lose fibre properties. There are two basic stages of it. Separation of the fibre bundles from the outer cuticle and the inner core, and then degradation of the cement that is actually holding the fibres themselves together, known as the middle lamellar components. These are mainly pectin, but with traces of lignin. So simplistically put, lignin behaves very much like a polyester resin. It is very, very difficult to degrade. It stays in the ground if you allow all plants to rot for anything up to 10 years without completely being degraded. Okay, what we're trying to do in the retting process is essentially separate the fibres from each other, and the sample here of retting flax showing the fibres, the intercellular cement between the fibres has in fact been removed. But you still have an outer cuticle which is essentially intact, and you have an inner part of the plant which is also essentially intact. Okay, retting can be undertaken in a number of ways. This presentation is certainly not complete. Water retting or tank retting, I was interested to find out, is still practiced here in Egypt. I only found this out this week, and I'll come to that in a moment. I've outlined a little bit about dew retting, and of course we know that post-harvest retting is an important alternative. And post-harvest retting using alkalis and other additives, using enzymes, and the thing that we've been looking at to try to improve the process of on-farm retting is retting the crop as a standing straw. And I'll come back to that in a moment. A typical picture of old retting tanks. We stopped retting in Europe by water retting, primarily because of the high pollution that it causes to the waterways, and it's a foul-smelling process. So unfortunately though, as far as quality is concerned, it actually produces the best fibre. Dew retting is a problem because it is uneven and it's labour intensive. These swathes of flax that are left in the farmland to rot, we'll say, to an acceptable standard, have to be turned regularly in order that the retting is an even process. Okay, when the plant is pulled and allowed to ret, natural fungi that are present in the soil and around colonise the flax straw and attack the flax, producing enzymes which themselves cause degradation. The problem here, of course, is that you get considerable variation of properties of the retting process. So we certainly have an awkward situation. The retting process with enzymes, and we're talking about enzyme retting in the natural environment, at least for the moment, you obviously get complete digestion, or can get complete digestion of the plant. You can attack your cellulose material, as opposed, and of course all the other components that are present, to get complete degradation of the fibre. What has been attempted is to post-harvest ret. In other words, you harvest the plant and then process it later. I mentioned earlier, and we saw earlier in Chris's lecture, that you can do this with chemicals. Enzymes are extensively being investigated for this type of process, using pectinases, but they're natural pectinases as commercial products, and they do contain xylases and cellulases. And of course, the cellulases in particular will attack cellulose, and this gives us problems, or can give us problems. The optimization of this process at the moment seems to be with the incorporation of EDTA, and if anyone wants to talk about that, I will do so later. But the most extensive publications on this topic are given by Dan Aitken from the the US Department of Agriculture, and he's published extensively on this. We have a series of problems. As far as de-retting is concerned, it's labour intensive. In Europe, it can only be accomplished economically with the help of very substantial subsidies. It tends to produce unevenly retted straw. The straw is contaminated by stones. Stones cause problems in mechanical processing. We often have problems with over-retting, particularly caused by the fact that you get rain in the autumn when you're wanting to harvest the crop, and if the crop is wet, you cannot harvest it. We have therefore a problem of consistency of supply. 80% of the North European flax was destroyed purely and simply by late autumn rains in the last season. Okay, and fully mature straw is high in lignin content and is difficult to bleach. What we're trying to do is look at selection of flax varieties. We're growing flax to a particular stage of its development before we kill it, kill it. We're using a systemic herbicide to kill the flax rather than pull it out of the ground. And I'll come back to that in a moment. We allow the flax to stand as a straw. In other words, we don't crop it. It's standing in the field as a straw, and we allow them to die and to be harvested by mowing and baling. And finally, we're looking at modification of the extraction processes. Very briefly, we're looking at flax varieties. We're looking at the moment at 85 different varieties of flax to see if we can improve the flax that we ought to be growing. This is a picture which shows us collecting the samples, which were grown in northern Europe at the Plant Research Institute in the Netherlands. We're looking at growth studies, fibre formation, lignification. Obviously, we're interested in straw yield and things like this. Desiccants terminate the plant growth. And if, for example, you see here a field sprayed with desiccant, the plants die. They then are attacked by the same sort of fungi that occur in water-retting, in dew-retting rather, and the crop rets as a standing crop. Just some examples here. You note at the bottom here very high levels of colour consistency. These are investigations of different kinds of desiccants, but the important thing here is the consistency of the colour, indicating that we have in fact got even application of our desiccant, and that leads to even retting. I'll skip this one. We're looking here at the yield of fibre, and we find that we don't, and this is at different times of desiccant application, we find that we maintain our fibre yield despite the fact that we kill the plant early. This is a very simple graph showing the crop height after midpoint flowering. We believe that at midpoint flowering all the fibre is formed, and we can then, from then on, desiccate and ret. And this is some weeks earlier than what would normally be done in flax fibre production, so that it shortens the growing cycle and makes it more efficient as a catch crop between other crops. I'll miss out the chemistry. Okay, colour is very important. Lignification causes the plants to go yellow. Lignin is difficult to bleach. So we're trying to identify low lignin varieties or plants in which we can desiccate the plant before the lignin fully matures. Okay, in general aims therefore, and this is almost at the end, we're looking for a commercially viable solution to improve the retting process. We want to eliminate the idea of crop failure caused by late harvesting and the effects of rain during the harvesting period. We're aiming to increase the quality and uniformity of the retting process, and we're looking for an easier extraction route from the fibre from the straw, and consistency automatically leads to an easier extraction process. And we're also aiming to improve the colour by selecting our whole harvesting, retting process at points in the growing cycle when the lignification is lower than it is at the end of the process. Okay, we've had two particular research grants on this work, and we're still working, in fact, on in-farm harvesting and retting of flax. One from the EU, this FAIR project, and the second one, which is the Science Research Council DEFRA project, and we thank our sponsors for this, that, ladies and gentlemen, gives you a very, very brief outline, but I'd love to take questions.